Good morning, friends. Good morning, students. In today's class, we will discuss metabolism of nucleotide, right? So, first of all, there are two basic molecules. First is purine, and second is pyrimidine. Okay. First of all, the students find it very difficult whether which is purine molecule and which is pyrimidine molecule, right? So, you can remember it by the mnemonic. The name is small, the name is big. Purine, it is the name is small and pyrimidine the name is big, right? अगर हम हिंदी में बोले तो बोला जाता है नाम नाम छोटा है काम बड़ा है, तो मॉलिक्यूल इज बिग. pyrimidine नाम बड़ा है लेकिन काम छोटा है, मॉलिक्यूल इज स्मॉल, राइट? एंड जो ये है, this is the big smaller molecule. So the small child always obeys his parents, right? So the numbering is 1 2 3 4 5 6. The numbering is clockwise, right? But when the child becomes adult, he mostly start disobeying his parents, right? So the molecule is big, it will not obey his parents, so it will not obey the clockwise rule. So the molecule is anti-clockwise. So numbering is 1 2 3 4 5 6 7 8 9, right? Now we will start with the sources of carbon atoms and nitrogen atoms, right? So first of all, this is C4, 5 and N7. They are derived from glycine, right? And N3 and N9, they are derived from glutamine, right? And N1 is derived from aspartate, right? And 2 and 6 carbon dioxide here is derived from carbon dioxide, right? And these two and 8 are derived from tetrahydrofolate. So this is formyl tetrahydrofolate, and this is N5 and 10 methylene tetrahydrofolate, right? So first nitrogen, the numbering begins from 1 and alphabet starts from A. So first nitrogen number 1, and for A for alphabet A, for A for aspartate. So here is aspartate. Second and 8 are derived from tetrahydrofolate. 3 and 9 nitrogen are derived from glutamine. C4, 5 and S have a derived from glycine, and 6 carbon from carbon dioxide, right? Now this is pyrimidine molecule. So we discussed that one is derived from aspartate in the same manner. This is carbon number 1, so it is derived from aspartate, right? Now we will divide the molecule into half. So this half is completely derived from aspartate, right? And here N3 is derived from glutamine, same here. Third is derived from glutamine, right? And 2 is derived from carbon dioxide, right? So now we will start with pre-nucleotide synthesis proper. First of all, the purines, they are dietary, they are non-essential, and they can be synthesized from amphibolic intermediates, right? So in pre-nucleotide synthesis, there are two major pathways. First is de novo synthesis, right? And the second is salvage pathway, right? This pathway is predominant pathway, right? Predominant pathway. This pathway operates particularly in brain and erythrocytes, right? So now we start with de novo synthesis. For de novo synthesis, we need first of all ribose 5-phosphate as the precursor molecule, right? So from ribose 5-phosphate, by total 11 steps, we will get IMP, right? From IMP, we can synthesize AMP and GMP, right? So these are monophosphates. By kinase reactions, they are converted to diphosphate and finally triphosphate, right? Similarly, in the same manner, GMP is converted to diphosphate, then triphosphate by kinase reactions by adding ATP, right? So these are triphosphate, but we also need deoxy, right? So for deoxyphosphates, we need enzyme ribonucleotide reductase, right? From normal, they are converted to deoxy by ribonucleotide reductase, right? Now we'll start with these 11 steps of de novo synthesis. Now these are the 11 steps which I have written for de novo synthesis. To remember them, remember first of all one thing, that wherever ATP is added, the enzyme will be synthetase, right? So this is the first step. We discussed earlier that ribose 5-phosphate is a precursor for the synthesis of final product, that is IMP, right? So ribose 5-phosphate is first converted to phosphoribosyl pyrophosphate, and here ATP is added, right? I told you that whenever ATP is added, the enzyme will be synthetase, and we are synthesizing phosphoribosyl pyrophosphate. The enzyme will be phosphoribosyl pyrophosphate synthetase, right? So we will get two pyrophosphates attached here. The molecule is phosphoribosyl pyrophosphate. Now in the next step, we have to add amine group here. So right. So in this step, we will add glutamine. The glutamine will donate amino group, and the enzyme is glutamyl amidose transferase, right? Now we got ribose 5-phosphoribosyl amine. Okay. Now here in the third and fourth step, we are adding glycine here. So in this step, I add glycine, and it is converted to 5-phosphoribosyl amine is converted to glycinamide ribosyl 5-phosphate, right? And here in the fourth and fifth step, we add N5 and 10 methylene tetrahydrofolate, right? So we'll get formyl glycinamide ribosyl 5-phosphate. And the next molecule, sixth one, is formyl glycinamidine ribosyl 5-phosphate. Here we will again add ATP, and the enzyme will be synthetase, right? In the six steps, we got formyl glycinamidine ribosyl 5-phosphate. Here ATP is required, so the enzyme is synthetase, and glutamine is also added, right? So I have written again here formyl glycinamidine ribosyl 5-phosphate, the sixth molecule, and here we get the second seventh molecule, that is amino imidazole ribosyl 5-phosphate, right? And this reaction requires ATP. So the reaction requiring ATP is always synthetase, right? Right. So we got amino imidazole ribosyl 5-phosphate, and the next molecule, eighth molecule, is amino imidazole carboxylase ribosyl 5-phosphate. So we are adding carbon dioxide here, right? and the enzyme is carboxylase, right? So we got aminoimidazole carboxylase ribosyl 5-phosphate. Now here it is converted into aminoimidazole succinyl carboxamide ribosyl 5-phosphate. So in order to convert it, we are adding aspartate, right? Aspartate is added, and in the next step we get fumarate out. Fumarate will come out and we will get aminoimidazole carboxamide ribosyl 5-phosphate. Here it is further converted into formyl aminoimidazole carboxylase ribosyl 5-phosphate, and there we require formyl transferase and N10 formyl is used, right? And finally we will get the molecule IMP. Here we will remove a water molecule and the reaction is carried by cyclohydrolase and the ring will close and we will get the final molecule, that is IMP. Now we have synthesized IMP. So I will give a short mnemonic to remember all these steps. The steps 1, 3, 5, 6 and 8, they all require ATP, right? So this step 1, 3, 5, 6 and 8, they will all require ATP, so the enzyme will be synthesized, right? In second and fifth step, we will require glutamine and glutamine here, right? And in third step, we add glycine molecule, right? In eighth step, aspartate goes in, and in ninth step, the fumarate comes out. And in step 4 and 10, right, we require tetrahydrofolate for action, right? Now there are we have already discussed there are 11 steps of de novo synthesis, and from de novo synthesis by total 11 steps we get IMP. From IMP will form AMP and GMP. From IMP will first form adenine succinate, and this reaction require aspartate and GTP. From adenine succinase we will get finally AMP, right? And in this reaction IMP is converted to xanthosine monophosphate by IMP dehydrogenase, and this reaction require NAD, and xanthosine monophosphate is further converted to guanosine monophosphate by ATP and glutamine, right? So remember one thing, there is some cross regulation. For the synthesis of GMP we require ATP, for the synthesis of AMP we require GTP. There is cross regulation, so both are required. And once we form nucleotide monophosphate like this, they are converted into deoxy as well by enzyme nucleotide reductase to convert them into corresponding deoxynucleotides, right? So once we get a monophosphate, it is converted into GDP by kinase reaction, and GDP is further converted into triphosphate by another kinase reaction. Similarly, AMP is converted to diphosphate and diphosphate to triphosphate by corresponding kinase reactions. If one phosphate is added in each step. So that finishes with our de novo synthesis. And please like the channel and subscribe the channel for further videos.